Welcome back. Welcome back to Learning with me, Ms. Killen, here at MPB. We are in our Unit 2 equations. We're looking today at Lesson 3. We are solving your equations. We are looking at A-REI.1 and CED1. I can use real-world scenarios to create and solve equations. So let's go ahead and dive in and see what we've got. When we justify, we tell what we have done and what we have used to come to the solution. Justification helps us explain our methods. Now, a lot of your practice and a lot of your problems are going to say justify your answer or what's the justification. It's just telling you to explain. Okay, you've got a $10 word to say explain it. So don't worry about the word justify or justification. Just know you have to explain. So here we go. Let's solve the following equation for t. Use the properties that we have learned. So we have 6 times t plus 3 minus 2 equals 2 minus t plus 16. Well, the first thing I need to do is get everything together and make it pretty. So, as we've learned, we distribute. So we have 6t plus 18 minus 2 equals 2. Let's put all the numbers together since that will be more easy for us to use. Minus t. And so since I move some things around, I can say that I use the commutative property. So next what I want to do is get like terms together. So I'm going to subtract these and have 6t minus 16, nope, plus 16, excuse me. And then I'm going to put these together and have 18 minus t. That is going to be my equivalent equation. All right, so the next thing I want to do is get like terms together on different sides. So what I'm going to do is 6t plus 16 minus 16 on both sides. So 18 minus 16 minus t. So it is an equivalent equation. I also used my subtraction property. So next thing, go ahead and make that a little bit easier to look at. So I'm going to have 6t, because those cancel out, equals 2 minus t. And what I did there, it shows that these are equivalent equations. Noticing I'm keeping everything on the same side and I'm making sure everything is balanced. So the next thing I want to do is get all of my variables together. So since I am subtracting my variable here, I'm going to add my variable here. So it would look like 6t plus t equals 2 minus t plus t. And what I did here with the equivalent equation is I used my addition property. So then I'm going to make that a little bit more clear at 7t equals 2. These are equivalent. Now, still need to get t by itself. So what I'm going to do is I am going to move the 7. And what I do to one side, I have to do to the other. So with this equivalent equation, I have used my division property. So then what I have is t equals 2 over 7. So I have gone from my long statement, put everything that's alike on one side, put all my variables on the other side, and come up with an equivalent equation of t equals 2 over 7. Good job, guys. All right, so let's see what's on our next slide. Now, let's look at a word problem. You must create the equation before you can solve the problem. Jadarius is saving money to buy a new phone before he goes off to college. The phone he wants costs $1,210. He already has $260 saved from working at the Sonic in town. If he saves $95 each week, how many weeks will it take him to have enough money to buy the phone? No taxes will be added. Let W be used as the variable. All right, so let's go ahead and annotate this passage. The cost, $1,210. He's already saved $260. So each week, he's going to put in $95. And they want to know how many weeks it's going to take. So I know that W equals my weeks. So let's go ahead and write this. So I know that whatever I put as my equation, it's going to equal $1,210. Now, what do I put to get that 1210? I take how much he has saved, which is $260, plus $95 each week. So now I'm simply solving or isolating my variable. So the first thing I'm going to do is move everything using opposite operation. So I have 95W equals 950. Since it is being multiplied, I am going to divide. So W equals 10. So I can say it takes 10 weeks to save the whole amount. I am writing a sentence to tell my whole thought. It's always good to make sure that you understand, yes, W equals 10, but what does that 10 mean? It means it's taking 10 weeks for him to gather all that money by just putting $95 a week in. So it's always good to know what your variables mean. All right, so let's look at the next one. Sometimes, and that's important, sometimes when you are solving equations, we will come across statements that will equal each other, like 3x equals 3x. No matter what I put in this equation, it is always going to be true. That means all real numbers can be my solution. Now, you are going to be introduced to a new symbol. This symbol looks just like this. Now, Ms. Killen, that's a funny looking R. It is. This R means all real numbers. Now, the reason we make a difference between real numbers is because the more you get into algebra, maybe not in Algebra 1, but you're going to get into Algebra 2 and further, you're going to get into the imaginary numbers. So you need to go ahead and say now it's all real numbers. It can't be the imaginary numbers. And when you get into those higher maths, you will have to include those imaginary numbers. So the funny looking R means all real numbers. All right, so here we go. Some examples of this: solve for the variable. So let's see. I see a parentheses, so I'm going to have to distribute and get 5x minus 10. Well, look at there. It's the same expression on both sides of the equation. So no matter what I do, no matter if I put 1 million in there, it's still going to make this equation true. So let's look at number 2. I have 3x plus 4 minus x equals 2x plus 4. Well, obviously that's not right. But if I look on the left side, I need to put my like terms together. So 3x minus an x, I'm left with 2x plus 4 on the left, and wouldn't you know, 2x plus 4 on the right. So I do have that all real numbers situation. So let's look at number 3. See my parentheses, I'm going to have to distribute. So I'm going to put 2x plus 6 on this side, which is exactly what is on the left side. So I can say that all real numbers could be said to be the answer to all 3 of these equations. All right? Sometimes you can't find any solutions that will make the equations true. Let's look at this. I have 3x plus 6 equals 3x plus 1. So let's just go ahead and put our like terms together. I'm going to put all of my numbers on the left side and put my variables on the right. So I'm going to subtract 1, and I'm left with 5. 3x plus 5 equals 3x. Now I'm going to subtract and put my variables on the other side. Can I have $5 and be broke at the same time? I can't. 5 cannot equal 0. So we're going to use this does not equal sign. It cannot equal that 0. So let's see. 5 will never equal 0. In this case, your answer would be no real solution. So we would put no real solutions. Now remember, maybe later on in some of our math we can look at some imaginary numbers for things, but as of right now we're just saying there's no real solution. So then let's see what else we've got. So this problem is going to show us exactly what we're talking about. Store A sells packs of markers for $3. Bailey buys some packs of markers and also pays a $5 shipping fee. Her total cost is the same as if she bought the same number of packs at $3 each with a $10 shipping fee at store B. So let's go ahead and write these equations. So if I have store A and I have store B, it says that she's got packs of markers for $3 and she pays a $5 shipping fee. So let's just use P for packs. That's just easy. So we have what? $3 per pack plus a $5 fee for shipping. And then at store B, we've got $3 each, but we've got $10 shipping. So I've got $3 per pack plus 10. So if I said it's the same, that's the same as using an equal sign. So let's see. Let's subtract 5. So I have 5. Let's subtract and put my p's here. Again, you cannot be broke and have $5 at the same time. So let's see what this says. Create an equation for store A, which we did. We created an equation for store B. See what you can solve for. Well, I can't solve for anything because 0 will never, ever, ever equal 5. So I would say no real solutions. So let's see. Let's do some practice. Solve for your variables. So I have 12x plus 5 equals 13. So let's go ahead and solve for this. I am subtracting 5 on both sides. So 12x equals 8. I'm dividing. So x equals 8 over 12. Always, always, always reduce your fractions. So that would be 2 over 3. All right, so let's do number 2. Make it a different color. So the first thing I'm going to have to do is distribute. So I'm distributing. So I'm going to have 4x minus 12 equals 2x plus 6. I'm going to put my variables on the left, my numbers on the right. So I'm going to subtract 2x on both sides and be left with 2x. And I'm also going to add 12 on both sides. And I'm going to equal 18. Isolating my variable, I'm going to divide by 2. X equals 9. So let's look at number 3. 6 times x plus 1 equals 6x plus 10. So let me get yet another color. Distribute. So I'm going to have 6x plus 6 equals 6x plus 10. So then I'm going to put my variables on the left, my numbers on the right. I'm going to subtract 6 on both sides, and I have 4. I'm going to subtract 6x on both sides and have 0. I cannot have anything equal 0 but 0. So let's do this last one. So I'm going to write it over here so I can have more room. All right, so here we go. I am putting my like terms together, and I'm going to use my swoosh method. So I have 8x, negative 3 minus 5 would be a negative 8. I'm going to put my variables on the left side, my numbers on the right. So I'm going to add 8 to both sides, get 16. Subtract 8x on both sides, get 0. So I have no real solution for number 4, and I have no real solution for number 3. Make sure that your math is correct, and you will see if you do or you do not have an equation that equals. Time for you to master. Make sure you're noticing the operation symbols and what is on each side of the equation so you know what you need to put together. Determine which of the following equations have the same solution or no solution. Indicate each equation. So what I'm going to want you to do is pause the video. You and your table partner or you by yourself work these, see what you get, and then come back to me. All right, here we go. Check my work as I'm working and see if you got the same thing I did. So here we go. So for A, I have 0.6 plus 0.4x equals negative x plus 2.6. So the first thing I'm going to do is put my like terms together. So I'm going to add x to both sides. Now, what's in front of every variable ever known to man? It's an understood 1. So I have 1.4x. So then what I'm going to do is I'm going to subtract this I'm going to subtract the 0.6 on both sides and get a 2. Since my 1.4 is being multiplied to my x, I'm going to divide on both sides, and my x equals roughly 1.428. All right, let's look at B. Before I can do anything, I've got to distribute. So I'm distributing. So I get 30x plus, use your calculator and do, if you need to, 15 times 3. And I have 45 equals 13 minus 5x. I'm going to put my variables on the left, my numbers on the right. Ms. Killen, do I have to do that? No, you don't. Ms. Killen is set in her ways, and so she puts her variables on the left, her numbers on the right. That's just what she does. So I'm adding 5x to both sides, and I have 35x. I'm subtracting 45 on both sides. So I have 13 minus 45, and I get a negative 32. I still need to get that by itself, so I'm dividing. Now, I can leave it as negative 32 over 35, or you can go lower and say x is approximately negative 0.914. Either way, you've got the answer. Okay, so let's look at C. First thing we're going to do is distribute. So let me go ahead and get a different color. And I'm going to distribute and get, I'm going to write it up here so we have plenty of room, 6x plus 9 equals, and then I have that 13 over 5 minus x. So now what I'm going to do, just to prove that we can put the variable on either side, I'm going to put the variables on the right and the numbers on the left. So I'm going to subtract 6x on both sides and get a negative 7x. Now, I have a positive 13 over 5, so I'm going to have to subtract that 13 over 5 on both sides. So I'm going to plug that into my calculator. I have 9 minus, and to put my fraction in, 13 over 5. And I get 32 over 5. I'm going to divide by that -7. So 32 over 5. And I'm going to hit my division sign, and it says answer. I'm going to put a -7. And it has -32 over 35. And that's my answer. Good job. Let's look at number 10 now. Let's look at D now. Still going to distribute and have 30x plus 45 plus 97 equals 110 minus, that should have an x behind it. I do apologize. So my D may look a little different than yours. I do apologize. So then I'm going to put my like terms together, add these two. So I have 45 plus 97, which is 142. So 30x plus 142 equals 110 minus 5x. I'm going to put all of my variables on the left side, my numbers on the right. So I'm adding 5x to both sides. So 35x, I'm going to subtract this 142 on both sides. So I take, in my calculator, 110 minus 142 and get a -32. To get that x by itself, I'm dividing. So my x equals -32 over 35. So we've answered the question, do these equations have a solution? And all of them prove yes, they do. Now, you may come across problems that say justify. The justification is in the math. The math shows why it has a solution. This is a solution because. It's your because that you're showing with your math. So when it says justify, you're just showing the math. You're showing step by step what you're doing. Never be afraid of that justification word. It just wants to see your math. Awesome. So let's see what's next. We don't want to forget how we use our properties to solve our equations. We use opposite operations. Sometimes equations will have the solution of all real numbers and what that symbol is. Remember, that symbol is the weird looking R. What do we say when an equation does not have a solution? We say there is no real solutions. I'm so glad that you're here working with us and learning with us about these equations. I'm having a great time. Thank you for learning with us here at MPB. I am Ms. Killen. Have a great day.